So guys, from today's session, we are going to learn the interfacing of Bluetooth with Arduino Uno programming and all. So first we can see the Uno. Sorry, this is the HC05 module. As you know, previously in the previous classes, you have seen the programs or simulation using the Uno boards. Same, this also can be done in the simulation. So, so HC05 is a Bluetooth device used for wireless communication with both enabled device like smartphone. It communicates with microcontroller using serial communication. Default settings of HC05 Bluetooth module can be changed using certain AT commands, as HC05 Bluetooth module has 3.3 watts level of RxTX. So receiver and transmitter and microcontroller can be detect 3.3 volts level. So there is no need to shift TX voltage level of HC05 module. But we need to shift the transmit voltage level from microcontroller to receiver of HC05 module. So here you can see the interfacing diagram of HC05 module with Arduino Uno. So Arduino Uno is connected to the HC05 module. Then here they kept the transistors of 1 kilo ohm and 2 kilo ohms. So as we have discussed in the previous classes, we can know that the default name for the Bluetooth will be HC05 and the default pin or password will be 0000 or 1234. So for example, here we will transmit data from smartphone via Bluetooth to the Arduino Uno and display it on a serial monitor of PC. So download and install a Bluetooth terminal application on your phone and use it to connect the HC05 Bluetooth module. Data is sent to the smartphone using the Bluetooth terminal application. So this is the coding of the Bluetooth like HC05 module interfacing with the Arduino Uno board. So in this program, we can see that including the software serial as a header, and the object name of the Bluetooth can be created as software serial Bluetooth. The RX and TX will be a 2,3. So void setup will be taken. So here BT stands for Bluetooth. Bluetooth began at a baud rate of 9,600 and serial begin with the baud rate of 9,600. So here serial stands for serial communication. And the next in the if loop, they are declaring the if data is available on the serial port. Here it means if BT dot available. This is the meaning of the checking the availability of data on the serial port. So if the data is present, then the data should be read by the monitor. Okay. So next. SIM 900A GSM module interfacing with Arduino Uno. So this was the SIM 900 GSM module. You can see this. So GSM stands for Global System for Mobile Communication. So it is a digital cellular system used for mobile devices. It is an international standard for mobile, which is widely used for long distance communication. So there are various GSM modules available in the market like SIM 900, SIM 700, SIM 800, 800, 5320, etc. So we use SIM 900 module allows users to send or receive data over GPRS, send or receive SMS, and make or receive voice calls. So SIM 900 module allows these features to the user. So the GSM or GPRS module uses USART communication to communicate with the microcontroller or PC terminal. AT commands are used to configure the module in different modes and to perform various functions like calling, posting data to a site, etc. So next, interfacing diagram of GSM 900A module to Arduino Uno board. You can see here. So now let's see an example. Monitoring temperature and calling a specific number. If the temperature increases beyond a certain value, if a certain message is received within a specified time after the call is placed, then a fan is turned on or LED turned on for demonstration. Here, an LM35 is used for measuring the temperature. If the temperature measured is more than 35 degrees, a call is placed to the number specified and the call is cut after 25 seconds. If the user responds with a cool down message, the fan is turned on, LED turned on for demonstration. Here, we will be using GPRS SIM 900 library by Seed Studio from GitHub. So this is the way we perform the SIM 900 GSM module with the interfacing of Arduino Uno. So this is the sketch for how do we perform the program for this. So we'll be including the GPRS shield Arduino as header, software serial as header, wire as header. So next, pin transmitter and pin receivers are fixed at 8 and 7 ports. So the bond rate will be as usual as 9600. There will be a specified phone number and the message length also is 160. So how the message should be, the message length or it should be in the characters. So next was the phone number. Phone number also will be the characters, and date and time also will be in the character range, which you're storing in the phone. Okay. Next, GPRS 900 test pin transmitter, pin receiver, and bonded was testing, and it consists of the LM35 pin and int 8 underscore 1 as A1. So serial combination bonded will be also at 9600. Then the pin mode has 4 as output. In the delay of 1000, serial println will be the similar initialization error. If the delay was not there, it will be shown as a success. So next program, like continuation in the next loop, we are testing the temperature. If the call is placed or not. If the call is placed, the temperature increases to the 35 degrees Celsius. If the call is not placed, there will be no change in the temperature. If the temperature reaches the 35 degrees Celsius, then the fan starts fan starts rotating and it says the call has placed and this call is placed we can know by indicating by an LED, and these programs will be kept in your group. So what are the function used here? So sim 900 underscore test dot read SMS. Like this function is used to read the message that is present at the location specified by message index. So message length is the size of the message that is to be read. So phone is a character array in which the phone number of the sender of the message is extracted. Date time is a character array in which the date and time when the message was received is extracted. So GPRS SIM 900 underscore test pin TX pin RX bonded. This is used to create an object named SIM 900 test. Can have any other valid name according to the user of the class GPRS. So this object was created in the class GPRS as the name SIM 900 underscore test. So next, it also defines the pins on Arduino board that are connected to the RX and TX pins of the SIM 900A module. It also defines the bond rate used for communicating between the board as module. Okay. Next, we see the ESP8266 Wi-Fi module interfacing with Arduino Uno. So ESP8266 was the Wi-Fi module. Now we are going to interfacing with this module with the Arduino Uno. So ESP8266 is the Wi-Fi module is low-cost standalone wireless transceiver that can be used for endpoint IoT developments. So here these are specifically saying that these are used for the endpoint IoT developments. So ESP8266 Wi-Fi module enables internet connectivity to embedded applications to uses TCP or UDP communication protocol to connect with server or client. So this is a picturization of ESP8266 Wi-Fi module. This is how it looks. So to communicate with the ESP8266 Wi-Fi module, microcontroller needs to use set of 80 commands. So microcontroller communicates with ESP826601 Wi-Fi module using UART having specified baud rate. So this has a default baud rate as 1,15,200. So to know more about this, we need to refer to the previous Wi-Fi modules which are discussed. So now let's see the interfacing diagram of ESP8266 with its interfacing with the Arduino Uno. So here we can see that clearly ESP8266 pins were transmitter, enable pin, reset pin, power pin, receiver, ground, and two input output pins. So TCP client using ESP8266 Wi-Fi module. So let's program Arduino Uno to configure the ESP8266 Wi-Fi module as TCP client and receive the data from the using Wi-Fi. Here we are using ThinkSpeak server for TCP client demo purpose. ThinkSpeak is an open IoT platform where anyone can visualize and analyze live data from their sensor devices. Also, we can perform some analysis on data posted by remote devices with MATLAB code in ThinkSpeak. So here you can see the 80 commands in green and responses in yellow. So 80 commands are in green and responses are in yellow. Once you bring that screenshot. So next for TCP send method, we use the below 80 command steps shown in the screenshot of the real time or serial terminal. We can see this. These are the commands used for connections of TCP UDP. So for accessing required functionality, that is TCP received or send make changes in program as per the given below. For TCP client receiver demo, so we will be using as define receive demo. For client send demo, we're using as define receive demo. Okay. So here you can see the difference between sending and receiving. For receiving, the comment line will be in the second line. For sending, the comment line will be as the first line. Okay. So we need to include some of the header files for ESP8266 as domain, port, API, write key, channel ID, and SSID. So the domain will be as API thingspeak.com and port will be 80 thingspeak. Right, API write key was the thingspeak write key. Channel ID was thingspeak channel ID. SSID was Wi-Fi SSID. So and also password which will be also used as Wi-Fi password. Okay. So now let's look into the program as we have discussed. So ESP826680 as header, and here it was receiving the files. Then the same as we know the header files as domain, port, API, write key, channel ID, SSID, and the password. So later these four steps have been taking place. So now let's see the ESP8266 responses. So at the client end, we need to check the ESP8266 responses. We can check it on the serial terminal of PC or laptop. Connect ESP8266 module transmitter pin to the receiver pin of the Arduino Uno used to receive of the USB to serial converter as shown in the below figure. Connect USB to the serial converter of the to PC or laptop. Open the serial terminal on the PC or laptop to see the ESP8266 responses for the AT command sent from the Arduino Uno. So here you can see the ThinkSpeak response with entry ID for data send success. So in response with the TCP send, we get the data entry number as shown in the figure. So that is 1131 and 1132 and so on. For TCP receive commands, we can see the below response of AS8266 on the serial port ThinkSpeak server. So this was the ThinkSpeak's response for the last updated server. So in response to TCP receive, we get the last entry data field one on TeamSpeak as shown in the figure. So for TCP send, we can see output of the server here. We are using TeamSpeak server as sending an incremented account on the field one on server. We get incremental count of the field one of the TeamSpeak server as shown in the figure below. So this is what you have learned today. So is anybody having any kind of doubts regarding these classes?